Welcome to lesson 9 of GMAT Math Basics. As always, if you don't need help with GMAT Math Basics, just head a little bit back in the feed for some more advanced topics. The questions that we're going to answer today revolve around long division. The first question we're going to answer is, how do you divide large numbers under time pressure when one small mistake can cost you the entire problem? And the answer is long division. The other question I want to answer is, what are the steps to performing long division efficiently? Let's jump right in. There's always the question of whether long division should be done in certain situations, and that's more of a strategic question that we will ask and answer in future episodes. For now, I just want to focus on the fundamentals of the technique. And so we're going to assume that you can make relatively good judgments about when long division should occur. So let's say, for the purposes of this lesson, that you have determined that on a GMAT question, the next best move during the problem is long division. So let me ask you, what is the first step to long division? Some of us are going to define this differently, but the way I like to think about it is setting up the problem visually. That's really the first step of long division. And unlike other long operations that we've discussed recently, you're not going to stack the numbers in long division the way you would if you're doing long addition or long subtraction or long multiplication. It's going to look a little different. We're going to write what's being divided, which I will sometimes call the dividend, but more often we'll call the numerator, because I think a lot of folks have strong associations with fractions. And when you think about numerators, you think about something being divided. So I'm going to use that terminology. But basically, we write what's being divided to the right of what is doing the dividing. And then we put a vertical line in between them. So it's almost like a fraction where the numerator like fell off to the right of the fraction, and the fraction bar like tumbled down and like is just sticking straight up out of the ground or something. I don't know. It's kind of a weird visual, but that's kind of how I like to think about it. Is the numerator goes to the right of the vertical line and the denominator goes to the left of the vertical line. And I like describing it that way because, again, it'll help you keep track of what's being divided and what's doing the dividing. Once we've got the denominator on the left and then the vertical line to the right of that, and then the numerator to the right of that vertical line, the last thing we're going to do in terms of visualizing is we're going to draw a horizontal line above the thing that we are dividing, so above the numerator. It almost maybe looks like you're like putting a roof on top of the numerator, if that makes any sense. So the thing doing the dividing, aka what you are dividing by, aka the denominator of the fraction, we're going to write that first. Then we're going to write a vertical line right to the right of that. Then we're going to write the thing being divided, aka the dividend, aka the numerator of a fraction. And then we are going to draw a horizontal line right above the numerator. And that will help you visualize long division well. There's definitely other conventions with this, but because most of the videos that you would watch online and most of the digital instruction out there is going to teach it this way, this is the way that I recommend learning it. And I think it'll make the rest of your GMAT studies just a lot simpler. So that's step one. It's just drawing it properly, setting up the problem properly. Step two, let's say you've got it set up properly. Ask yourself, do you remember what to do next in a long division problem? Once you've got it drawn out, the next step is you're going to try to divide the leftmost digit of the numerator by the entire denominator. So this is a little different than other long operations. Most other long operations are going to start with the units digit, the digit to the far right of the number. Long division is the opposite. Long division, we start by trying to divide the leftmost digit, so the largest digit in the numerator, by the entire denominator. So we're not going to be separating digits in the denominator, but we are going to be separating digits in the numerator. Let's use an example. So let's say we're going to do 96 divided by 3. I've said this many times. Many of you probably could do this in your head, but that's not the point. The point is to understand the basics of the technique. So the first step is we're going to write the number 3, which I'm going to call the denominator. Then we're going to write a vertical line right to the right of that. And then we are going to write 96 right to the right of that vertical line. And that's going to be what I'll call the numerator. Then I'm going to draw a horizontal line right above 96, kind of like putting a roof over it. So the next step is we try to divide the leftmost digit, again, just repeating this, by the entire denominator. So the leftmost digit of 96 is 9. The denominator is just 3 because we're doing 96 divided by 3. And so I just do 9 divided by 3. I take that first digit, leftmost digit of the numerator, divide it by the entire denominator. In this case, that's 9 divided by 3. That's great news because 3 goes evenly into 9 3 times. And that brings us to the third step. Once you have the result of that first division, you're going to write that result right above the leftmost digit of the numerator. So we write a 3, because 9 divided by 3 is 3, which is called the quotient or the result of 9 divided by 3. We write that above the 9 from 96, right above the horizontal line we drew there. So the horizontal line in this case is just like the result line from long addition and long subtraction, but now it goes above instead of below the operations we're doing. Let's just recap the first 3 steps. You draw it out, you divide the leftmost digit of the numerator by the denominator, and then you write the result of that above the leftmost digit of the numerator. Those are the first 3 steps. So that brings us to the fourth step. The fourth step is we are going to multiply the result we just got by the denominator itself. And we will write the result of that below the leftmost digit of the numerator. So there's a lot to keep track of visually. If you're in a situation where you can draw this out as I'm going through it, I would highly recommend that. Otherwise, just use your imagination to the fullest extent you can. If you're riding a bike or going for a run or something, just try to visualize this in your mind's eye as much as possible. And then when you're back in a situation where you can write it out, I'd strongly recommend that. And none of this is meant to be done in your head. It's all meant to be done by hand on paper. So like I said, the next step is we multiply the result we just got by the denominator and we write that result below the leftmost digit. So I'm going to take the 3 that's above the result line, which was the quotient of 9 divided by 3, and I'm going to multiply that times the denominator, which is also 3. And the result of that is 9. And so I'm going to write that 9 right below the 9 from 96. And this will happen sometimes where you've got like lots of 3s and 9s moving around. The fifth step, after you've done that multiplication and written the result below the leftmost digit of the numerator, is now we are going to subtract the result of the multiplication that we just did from the leftmost digit of the numerator. Now, in this case, we're going to subtract the 9 that we just wrote from the 9 in 96, and that's going to yield 0. So we write the result of that subtraction below or at the bottom of the leftmost column. So underneath, so in that column, if you think about 96 divided by 3 for long division, right above 9 from 96, we've got the 3 written from our first division. Right below the 9 from 96, we've got 9 from our multiplication step. And then when we've subtracted those 2 9s, we write 0 right below that. Some people like to put a little line for the long subtraction that they're visually doing there, and I recommend that. It can help you stay organized. So now we've got a 0 in what I would call like the tens digit of the result or the numerator part of the number. Now the 6th step is we're going to do what's called bringing down. So we're going to bring down the 6 from 96, which is the digit right to the right of what we were just working on. And we're going to bring that down to the bottom of the work that we have completed so far in the problem. So The bottom of the work is the 0 in the tens digit column, and we're going to bring down the 6 in the units digit column and write that 6 right to the right of 0. That's a lot of steps. The more you practice this, if it's been a minute, the easier and more natural it's going to get. Eventually, you won't even have to think about it. It'll just be like totally natural. But there might be a little bit of friction between now and then, and that's okay. That's okay. When I was relearning long division after, gosh, I don't know, 10, 20 years of not having done it, it took me a minute. It was a little rusty, but after a little bit of practice, everything was smooth sailing. And if I can do it, I'm sure you can as well. Now, to help make this a little easier to remember, some people like to use an acronym to help recall those steps. And an acronym, if you're not familiar with that word, is just a series of letters that represent words. So the series of letters in this acronym are going to be DMSB. DMSB, which stands for divide, multiply, subtract, bring down. That's the basic formula, if you will, of long division. DMSB, divide, multiply, subtract, bring down. We're just going to end up repeating that cycle of dividing, multiplying, subtracting, bringing down over and over and over again until we get to the end result. So I'll walk you through a few more examples of this. But that's the DMSB acronym, and I'm going to use that. And what I like to do is make up like a memory trick for these acronyms, these series of letters that represent the steps. And it's usually easy for me to remember the little memory trick. I'll make it something like funny or zany or whatever. And then when I remember the memory trick, I can remember the order that the letters go in. And if I can remember the order that the letters go in, then I can remember the steps that I'm supposed to take and the order of those steps, which is important. The order of those steps is quite important in long division. So I just made something up off the top of my head for DMSB. I put don't make small bets. And like I just thought it was like kind of silly and but like it kind of made sense as a phrase. So just whatever's appealing to you. Learning science research shows that the more bizarre and zany that you make your acronym and what it stands for, the better you're actually going to recall it, which I thought is kind of like a little fun fact. But back to the core lesson, let's assume that you can memorize and make up something for DMSB, which is divide, multiply, subtract, bring down. So the next step after what we just did is to DMSB again. So if you think about it, we DMSB'd at the beginning. We divided 9 by 3, which was the first digit of 96. We wrote that above the 9. We multiplied that result times the denominator. And then we subtracted that result from the digit, the tens digit of 96. And then we brought down the 6 right to the right of that. That's divide, multiply, subtract, bring down. Let's repeat that again, and I'll show you how this works. So if we return to our example of 96 divided by 3, we will just rehash real quick. So we first visualized it, 3 vertical line, then 96, then horizontal line above 96. Then we DMSB'd, divided 9 by 3, wrote the result above 9, multiply that result, write that below 9, subtract, bring down the digit to the right, which is 6. So now we will pick up from that point and DMSB again. But instead of using the original numerator, we're going to divide the resulting number from the bringing down step. So if you imagine that 0, 6 at the bottom of all of our work, I'm going to take the denominator 3 and I'm going to divide that into 6. Now that just so happens to be the exact units digit of 96, but that will not always be the case. This is just like a simple, convenient example where that happens to work out. So we can't rely on that. Now, because 9 minus 9 was 0, and we brought down the 6, we divide that result 6 by the original denominator, which is 3, and we write the result of that division at the very top of the column we just brought down from. So we are working in columns again, just like the other long operations methods, except now we're going from left to right with long division. Whereas previously in long addition and long subtraction and long multiplication, we moved from right to left. It's this very, very, very similar concept. Because when we divide 6 by 3, we get 2, then 2 is the result that we write at the top of the column, right above the 6, above the line from 96, and the line that's right above 96 that we drew at the beginning. So above 96, we've got 32 written, and there's a good reason for that, because that is the result of 96 divided by 3. And once you have run out of digits in the numerator to divide by, you're done. Sorry, not to divide by, but to divide into. Excuse me. Slight subtle shift there. But 96, once we run out of digits to divide by 3, we're dividing 96 by 3. Once we run out of those digits, we're done. And those are the basic ingredients of long division. So all I want to explore for the rest of this episode is a couple other situations that can happen, give you a couple examples, and just make sure that you are set up for success. So there's not too much weird stuff that happens with long division, but the first thing that is a little different and a little bit of a next step beyond what we just talked about is when you cannot divide one of the digits of the numerator by the denominator. That can happen sometimes. So let's talk about what to do when that happens. Let's use an example. Let's use 105 divided by 5. Again, you could probably do that in your head for a lot of you, but it's just to illustrate the technique. What's the first step? What's the first step of long division? If we want to do 105 divided by 5 with long division, what would you do first? Hopefully you're thinking visualize it. So we're going to write a 5, which is the denominator. Then we're going to write a vertical bar right to the right of that. And then we are going to write 105 right to the right of that vertical bar. And then we will put a horizontal line on top of 105. The next step, what do we do? Hopefully you're thinking either DMSB or just divide. Either way works. So first, we would like to divide the 1 from 105 by the 5 from the denominator, but we cannot divide 1 by 5. It's not big enough. 1 is not a large enough number for 5 to divide into. So what do we do in that kind of situation with long division? Well, you just write a 0 at the top of that column. And you just want to think about it as 5 goes into 1 0 whole times. We can fit 0 5s in the number 1. So we write a 0 right above the 1 from 105 in the result column. And then we just repeat the process. We just DMSB from there. It is really that simple. Anytime you can't get the denominator to fit into one of the digits you're dividing by, just put a 0 at the top of that digit and run the same exact approach that you would before. So let's finish this out just so you can hopefully experience this in action. So we just D'd from DMSB. Now we will M from DMSB. So we're going to multiply the result, which is 0 times 5, the denominator, and we're going to write that right below the 1 from 105. 0 times 5 is 0, so we write a 0 right below the 1. Then we do the S from DMSB. We subtract. 1 minus 0 is just 1, so we write that at the bottom of the hundreds digit column in this case. So in the hundreds digit column, we've got a 0 at the top, right above the result line. Then we've got the 1 from 105 right below that. Then we've got the 0 from 0 times 5 right below that. And then we've got the 1 from subtracting that 0 from 1 below the result line. Then we do the B from DMSB, and we bring down the digit to the right from the numerator. So that is going to be the 0 from 105. We bring down the 0 from 105, and you'll notice that in this situation, that makes the number 10. We've got the 1 that we got from the subtraction, and then we've got the 0 brought down, and you want to think about that number when that happens as 1 0 or just 10. At this point, what do we do? Do you remember what to do at this point? After you DMSB, you just DMSB again, and you just keep doing that until there's no more digits in the numerator. So let's do it. Again, we're not going to divide the numerator itself anymore. We're going to divide the result that we just got from bringing down. So that's 10. We're going to divide that 10 by 5, the denominator. And 10 divided by 5 is 2. And we write that result of 2 at the top of the column that we just brought down from. So in this case, that'd be the tens digit column if we're thinking about 105. So right above that 0 from 105, above the result line, we'll write a 2. And that's the next number in our result, next digit in our result. I would ask what the next step is, but honestly, I'm getting tired of myself saying it. So we just DMSB again. And hopefully you can see how this cycle is going to repeat. So now we just divided from DMSB. Now we're going to multiply that 2 that we just got times the 5, which is the denominator, and we're going to write that result at the bottom of the column that we are working on, the column of the result we just got. So that 2 times the 5 is going to yield 10. And we write that below the 10 that we just divided into. So at the bottom of that work, we write the 10. And then we just subtract. 10 minus 10 is 0. And then we bring down. So we're just dividing, multiplying, subtracting, bringing down. So we divided the 10 that we got from the first step by 5. That gave us 2. We wrote that at the top of the tens digit column. We did 2 times 5 gave us 10. And we just write that right below the tens digit column that we just did. And we just subtract the previous number. Sorry, we just subtract the result from the previous number. So 10 minus 10 is 0. And then we bring down. So it's just DMSB. So we bring down the 5 from 105. And that's going to be 0, 5 now at the bottom of our work. And then we just DMSB again. We divide. So we divide the 5 at the bottom of that work by the 5 that's in the denominator. 5 divided by 5 is 1, and we write that result at the top of the column we just brought down from. So again, we're just repeating this cycle over and over and over again, moving from left to right. So that puts a 1 right above the result line, right above the 5 from 105. We just divided. So we now MSB, we multiply the 1 from that result times the 5 that's in the denominator. 1 times 5 is 5, so we write that at the bottom of the column we just got the result in this case, the units digit column. And then we subtract. 5 from the previous bringing down minus 5 from the multiplying step is 0. And there's no other numbers to bring down. So that means we're done. So what's the result when we divide 105 by 5? It's 21. Now at the top, if you followed my directions, it would be 0 to 1. But hopefully you know that 0 to 1 and 21 have exactly the same value. So those are the basics, plus a few rounds of DMSB to just illustrate that it's always the same thing, plus what to do when one digit does not divide into another single digit. You just write a 0 at the top of that column and continue to the right with the DMSB process. Now, there's one last thing, which is what happens when you divide and you do not get an integer. Let's try that out. So in the 2 examples I just gave you, we were dividing something evenly. But let's do something like 107 divided by 3. You might already know or suspect that 107 is not a multiple of 3. 3 is not going to divide evenly. So what happens when we do that? Well, let's run through the steps. I'm going to go a little quicker this time. First, we visualize. We write 3, then the vertical line right to the right of that, then 107 right to the right of that, and then a horizontal line above the 107. Then we DMSB. We try to divide 1, the first number in 107, by 3, but we can't do that. So we write a 0 above the 1, and then we multiply that 0 times the 3, that's the denominator. That equals 0, and we write that below the 1 from 107, and then we subtract. 1 minus 0 is 1. So we write that at the bottom of that column, and then we bring down the 0 from 107. That makes 10. And hopefully that's pretty familiar from the example we just walked through, just slightly different numbers, but a very similar result. So then we DMSB again. We divide the result from bringing down by 3, which is the denominator. And 3 can divide into 10 3 times, but there's going to be a remainder. That's no problem, though. When that happens, you just write the quotient, how many times 3 can actually go into 10 evenly, at the top of the column you just brought down from. So that's the tens column in this case, and then you just repeat that process. So because the quotient, when we divide 10 by 3, is 3, we can fit 3 3s into 10 before we get into a situation where we can't fit any more whole 3s in there. So that 3, that quotient, goes in the result column at the top of the tens column right above the 0 from 107. That's it. When it doesn't go in evenly, you just take the quotient and you don't worry about the remainder in this part of the process. So we divided, now we multiply. So we multiply the 3 that we just got in the result at the top of the tens column, right above the 0 from 107, times the 3 that's doing the dividing, the denominator, and that yields 9. And we write that at the bottom of the column that we just got the results from. So that's the tens digit column. So this is very, very similar steps process-wise. It's just, I don't want you to get hung up if you wind up dividing by something that yields a remainder. It's totally fine, totally normal. So then we're going to subtract that 9 that we just got from 3 times 3 from the 10 that we got from bringing down. So 10 minus 9 is 1, and so we write that at the bottom of the column that we got the result in, which is the tens digit column. Then we just bring down. So it's just DMSB again. We've got the 7 at the end of 107, so we bring that down to the bottom of the units digit column, and we write it to the right of the 1 that we just got from subtracting. That makes the number 17. So just like I said in previous episodes, if this is just getting a little intense to like follow all the specific numbers, don't worry about that if you're on the pure audio feed. Just think about the process and the steps. Try to remember the basics so that when you're at a situation where you can write this out, it's not a totally foreign concept. So we've brought down the 7 from 107, and we put that next to the 1 from 10 minus 9, and we've got 17. So what do we do at that point? We just DMSB again. So we divide 17 by 3, the original divisor. Again, we're not dividing anything in 107 after the first division by the denominator. We're dividing the results at the bottom of our work by the denominator now. And again, 3 does not divide 17 evenly, but that's totally fine. We just write the quotient at the top of the column we just brought down from. So 17 divided by 3 is 5 plus a little bit of a remainder. Because we can fit 3 into 15 evenly, but not into, we can't fit another 3 on top of that into 17. So we can fit 5 3s into 17 before we like run out of room, if you think about it that way. So at that point, we just write that 5, that quotient, at the very top of the units digit column. Now, real quick, let's just address this. You might be thinking, wait, there's a remainder of 2 when I divide 17 by 3. If you're not sure what remainders are or what I'm talking about there with fitting numbers into other numbers, then just go back to lesson 4 and lesson 5 of this series. There are a few episodes back in time, and that'll really help with those division and remainders concepts. But for now, again, we can fit 5 3s into 17, so 5 becomes the quotient. We write that at the top of the column we just brought down from, which is right above the 7 in 107. So we write a 5 right up there. Now let's do one more round of multiplying, subtracting, and bringing down to finish this out. So we multiply 5, the result that we just got, times the 3, which is the denominator, to get 15. We write that below the 17, the previous result, and then we subtract to get 2. Now at this point, there's nothing left to bring down, and so we're just done. And the way you will express that is there's a remainder of 2 when you divide 107 by 3. So the quotient there is 35. That's the 3 and the 5 that we got from our original division steps, with a remainder of 2 after that. And we've already discussed the sort of naming and writing conventions of remainders in the past. Most of us would write 35 and then an R right to the right of that, the letter R, and then a 2 right to the right of that. That's it. Those are pretty much all the outcomes you could face with long division, with just a couple exceptions that we'll cover in the next lesson. When we get to decimals and long division, which we will get into very soon, there's a little bit more to know, but the foundation and the basic techniques are going to be the same. We're just going to add a little bit of nuance and a couple extra tools to the core basics of visualizing and then doing the DMSB cycle over and over and over again. But if we tried to go into that here, which we experimented with on our side, it tended to make the whole lesson here a lot more confusing. So let's just take a pause. You can practice some long division, and we will be creating some tools for that in the future. So be on the lookout for that. I'll make an official announcement in one of these episodes when we are ready to launch that. And we will backtrack that so you'll have that for the whole program at a certain point. But I'm not going to make any promises on timelines because we want to make sure that that material is really well done for you. If we're going to do it, we want to do it well, basically. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content if you want to click rather than type. And check out our video on our website there about how to reach your dream GMAT score in half the normal time. It will save you tons of pain and suffering and time that you can do so many wonderful things with that are not studying for the GMAT. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. You matter, your career matters, and your results on this exam matter. You can definitely do it. It's more than worth it, even if it might be a little bit of a struggle right now. And if you're not struggling, that's awesome too. I'll talk to you all soon.